So, oh my goodness, I had recorded, like if I was recording for, I was streaming for an hour before and I had to delete it, and oh my goodness, because I thought it was, what is it called? I thought it was the sound was on and it wasn't. Okay, so we're gonna do rational functions. We're gonna do multiplying rational functions. So yeah, let's get started. So let me start with a very simple one. Okay, this is pretty simple. It's not as bad as, you know, as we think. You know, obviously with fractions, if you remember from like 8th grade or, you know, like middle school math, they would give you something like 1/8 times, I don't know, like 4/5, and you were like, oh, well, this is 4 over 40, right? And then you would say, oh, this is 1 over 10, right? Now, in algebra, specifically algebra 2 and college algebra, they want you to know how to do like multiplication with the rational functions. This is a very important skill because, well, yes, when you do rational equations and you're factoring everything, you want to know how they cancel out, right? This one says 1 times x squared over, or 1 over x times x squared over y. So this is pretty easy. The first thing you're going to do, you're going to get x squared. So you're going to put x squared over xy, right? This means that we have x times x over x times y. Cancel that out, you get x over y, right? And so that's how it's done. This is a very simple one, right? We haven't gotten to the hard part yet. You know, we're still kind of like, you know, we're still in the basics. I'll just say that we're in the basics. Know that not every, like, basically not, just like when I said, you know, just like how I used to say, well, when we have x plus 1 equals 0, and I would say, well, not every linear equation is that simple. And when I would say x squared minus 1 equals 0, not every quadratic equation is that simple. Well, now, with multiplying rational functions, not every product, or like not every problem of these is that simple. You have to do a little bit of math, right? So we're going to go over a few examples with these. And this is, you know, obviously I'm not going to do rational equations yet. That will be tomorrow. Because, yes, it's late. And I don't want to do too much. So, let me see. Now, we're just gonna dive right in. Because obviously, and of course I'm not gonna go too fast, I'm gonna go pretty slowly. So I'm not gonna be like doing all this math like crazy and just being like, okay, well that's the final answer. I'm gonna do my best to explain, okay, like, you know, how did we get there? What did we do, etc. Let's do this problem. This is going to be number 1 for our problem. And it's not on the, like, it's on the textbook, but it's an example. It's not like a practice problem. That's like on the practice section. So we have x squared plus 4x minus 5 over 3x plus 18 times 2x minus 1 over x plus 5, right? So we're going to factor the top and the bottom, right? We have, remember how to factor quadratics, you do 1 times 5, or 1 times negative 5 is negative 5, and then you do the middle part, you put it on the bottom, so it's going to be 4, and then you have negative 1 and 5, and since it's a leading coefficient of 1, we're just going to have x minus 1 times x plus 5. So this is written as, and let me, if I rewrite the problem, I'm going to rewrite the problem so that y'all know what I'm doing and y'all know what's changing and everything like that, because I don't want to just do it and then everybody's like, wait, how did you do this part? How did you do this part? Let me, hold on guys. Where is the brown marker now that I think about it? Oh, it's over here. Hold on. Okay, hold on guys. Let me grab it. Oh my goodness. Sorry about that, guys. It was in the back of the board. So let me use the brown marker. So if I rewrite it, so let me just rewrite this problem. X squared plus 4x minus 5 divided by, oh, excuse me, divided by 3x plus 18. And then times let me use this one. Two x minus 1, right? And then over I'm gonna do x plus 5. Okay. So they're all in different colors. These, actually, let me change this color here, because I don't want to make it look like, I really don't want to use that one. Actually, now that I think about it, because they look almost the same. Let me do purple. I don't know if purple would look good. Actually, I don't know if I want to do purple, because purple is not... I'll do green. Okay. So let me just explain what I'm doing. So basically, you're going to factor everything, okay? Now, like I said, if there's one part that's not factorable, you're gonna leave it as it is. So first we're gonna factor, so factor x squared plus 4x minus 5, okay? We're going to do our x box. 1 times negative 5 is negative 5, and then the b part. So then two numbers that multiply to negative 5 and add to 4 are 5 and negative 1. So because a is equal to 1, we just say x plus 5 times x minus 1, okay? That's exactly what I did here. It's exactly what I did here. I'm just rewriting it. And let me go ahead and just erase this part. So these two, this is the same problem. I'm just make sure I'm color coding it. And then actually, I'm going to say 2x minus 1 is not factorable without fractions. Okay. So it's going to stay as it is, right? 2x minus 1 stays as it is. 3x plus 18. Now 3x plus 18 is different. What marker did I use? Did I use this one? Right? 3x plus 18 is factored as 3 times the quantity x plus 6. You can factor 3 out. Okay? X plus 5. Okay, x plus 5 is not factorable. Therefore, or thus, we have the following. It's going to be x plus 5 times x minus 1 over, this is the x squared plus 4x minus 5 over 3 times x plus 6 times 2x minus 1 over x plus 5. Now, you're going to bring it together, okay? You're going to bring it together. You're going to say this equals this following fraction, x plus 1 times x plus 5 times 2x plus 1, minus 1, excuse me. Over 3 times x plus 6 times x plus 5. Now notice that these two cancel out, right? These two cancel out. So then we have x plus 1 times 2x minus 1 over 3x plus 18, or x plus 1 times 2x minus 1 over 3 times the quantity x minus 6, or 3 times the quantity x plus 6, excuse me, or x squared, 2x squared, right? 2x squared. It's going to be 2x squared minus x plus 2x, so plus x minus 1 over 3x plus 18. It doesn't matter. These are all equal, okay? There's nothing that cancels out anymore, so you can write it however you want. But if it's multiple choice, you want to make sure that you factor everything and you see, okay, which one is equal to this, okay? So that's how you do this one. Let me go ahead and do, hold on. Give me a second, guys. We're going to do 5 of these, and then we're going to do 5 division ones, and then we're going to be done. So we have... Or no, actually, let's do 4, because I feel like they're very long. Let's do 4 instead. 4 of each. So we have... Let me try to pick a good one. X squared minus x minus 6. And, hold on guys. X squared minus x minus 6 over 2x squared minus, or 2x squared plus x minus 6 times 2x squared plus 7x minus 15 over x squared minus 9. Okay. So we're going to go ahead and do this one. First, we're going to factor this one. So, number 1, factor x squared minus x minus 6, okay? We're going to do that. We have negative 6, negative 1, so then we have negative 5, oh, basically, it's going to be negative 3 and 2, so it's going to be x minus 3 times x plus 2, right? So that means we have right? We're not done factoring. You're going to then factor this one. So you're going to say factor factor 2x squared plus 7x minus 15. Now this is one where we have to use the box method. So we have negative 30 and 7, right? Then we're going to say this is negative 3 and 10. And we're going to draw our box. We're going to put 2x squared right here. Negative 3x, 10x, and negative 15. Then we have x and 2x. Or actually, hold on. Let me see. It would be so let me do negative, let's do 10x and then negative 3x, because then like in these two parts, it doesn't matter how it, like, you have to be careful so that it factors right. So basically, so we have x, or 2x and x, negative 3 and x, and then 2x and 5, and negative 3 and 5. So then we have 2x minus 3 times x plus 5, right? So then that changes our function to x minus 3 times x plus 2 times x minus 3 times x plus 5 over 2x squared plus x minus 6 times x squared minus 9, right? And then we're going to factor, we're going to factor 2x squared plus x minus 6. So we have negative 12, and then we have a 1. So then two numbers that multiply to negative 12 and that's a 1, it's negative 3 and 4. We do our box method. 2x squared, negative 3x, 4x, and negative 6. Let me make that bigger. Right. Let me actually put this more higher a little bit, like this, so that it's not... Okay, so we have x, 2x, 2x, and 2 and, or sorry, 2 and, it would be 2 and 2x, and then we have a negative 3. So then this would be 2x minus 3 times x plus 2, and then our x squared minus 9, which is basically the last part. It's x squared minus a squared equals x minus a times x plus a, right? That's the product of two squares pattern. We're gonna have so let me basically we have what is it called? We have the product of two squares pattern, and this simplifies to x plus 3 times x minus 3, okay? So now that we have everything factored, we're going to say that this entire part is so it's going to be x minus 3 times x plus 2 right? So basically we have x minus 3 times x plus 2 over 2x minus 3 times x plus 5 times the quantity 2x minus 3 times x plus 5 over x plus 3 times x minus 3. Okay, so we have something like this. We cancel these out. We cancel these out. And we're left with x plus 2 over x plus 3. Okay, so that's our final answer for that one. I might cut this video short, guys, because it's getting kind of late. But, yeah. Basically, what you have to do, the main idea with rational functions, when you're multiplying, what you have to do is you have to factor top and bottom, and you have to see, okay, which ones cancel. You have to factor, like, literally you have to factor every one of these and then say, okay, what factors cancel? That's how it all works. I'm gonna move dividing rational functions to tomorrow because it's getting kind of late and I'm getting kind of tired. Yeah, this was a pretty short stream. I'm not really gonna stream for that long because I really, well, yeah, it's not, I kind of did this a little bit late, so we're gonna continue with this tomorrow. If you guys have any questions for me, please let me know. Please like this video, comment, and or subscribe. And for this stream, please, you know, whoever watches it, if you do watch it, I would really appreciate the likes and the subscriptions. So yeah, with that being said, guys, I think I'm gonna continue this tomorrow, and I will see you guys next time. Bye, guys.